My name is Haleem Tamale and this is Ivan Mugarura, and we're both physics students at Torres International School in Jinja, and today we're going to be talking about electricity. Particularly, we're going to show that water is a good conductor of electricity, and then later on we're going to demonstrate an application of this process. So the requirements for this experiment are going to be: you need some wires, an indicator, something to show that current's flowing through the wires, and in this case we're going to use a bulb. You're going to need a source of current, which is our system over there, and some water. So my colleague is first going to test out if everything is working perfectly. As you can see, the bulb's lighting up properly, so everything is okay. So he's going to place these wires into the water. And as you can see, the wires are not touching each other, but the bulb's still lighting up, which shows that current is still flowing through the circuit. And this is proof that water is a conductor of electricity. But as amazing as this may seem, this can have a downside, and I'll give you one scenario. If there's water spills on the ground and a bare wire touches the water, and then a person goes and touches the same water, they're going to receive an electric shock, and this sometimes can be fatal. But as bad as that may sound, there's an upside to this, and that's what we're going to move on to. So as you can see here, the project is labeled water level indicator, and that basically sums it up. We used a model to demonstrate this in everyday use. So a family with their home having a water tank, and so this system is going to basically show that water in the tank is either less than required or enough to sustain the family. So our system is composed of some wires. We have contacts placed in the bucket at various heights. One contact high up and one contact down low. As you can see here, high and low. And this basically represents a high water level in the tank and a low water level in the tank. And then also we have our indicator here that shows you the water level is high or the water level is low. And if it's low, the bulb will light up. If it's high, the bulb will light up correspondingly. So we're going to demonstrate this, as my colleague will add some water there. And first turn on. So the water level has met the contact in the bucket that represents low. So this light bulb will automatically come on. As he adds in more water, the light bulb representing a high water level also comes on to show that an adequate amount of water is currently present in the tank. And this is just a basic model, but in day-to-day life, this system could be vastly improved to have an automatic pump and a microprocessor that receives input from these light bulbs and automatically switches on the pump to send water to the tank when the water level is low. And if one person cannot know if you're going to use a manual pump, if this light bulb representing a low water level also goes off, you can easily know that your water tank is almost empty, and you switch on your tank and fill it up once again. So this proof has various uses, and one of them could be a rain alarm system. For example, you're a farmer, you left your crops out outside, but it's late at night, so you can't keep an eye on them all night long. You could have a system set up on your roof that once water falls onto the detector, a siren will go off in your house and you'll know, oh, it's going to rain, I have to get my crops out from outside, and you end up not making a loss, and you receive your income and the fruits of your hard work. Thank you. That will be all.